Hey everybody, this is Larry, this is me going with Q2 of the bi-weekly contest 154, number of unique XOR triplets 1. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one, I think the tempting thing to do is of course just do like a linear, like an n cube thing, but of course n is too big, so you can't do it. N is a little bit small, but the key thing is that it is a permutation. Honestly, I don't know if the order matters for this problem, and I mean, well, it turns out that it doesn't. But as a result of this, I thought that it may not matter for Q3, which was wrong. But the key observation here is that you're basically given every number from 1 to n, right, in some order. So then the idea is that, okay, how can you construct these numbers? Well, the first observation that I had was that, of course, if you have the number x for any x, you XOR with itself and then itself again, it'll give you number x. And because you could do this for any number from 1 to n, your answer is going to be at least n. And then the other thing is that if you have three numbers, a mod, b, XOR is equal to 0, then you also get 0, right? And of course, this happens when you have 1, 2, and 3. So that means that for n is greater than or equal to 3, this is true. Okay, so it turns out that, and honestly, I don't quite know how to prove this during the contest. I was just I didn't have any idea, right? And if you watch the live portion, you'll see that I just did the n cube for loop. I did the n cube for loop and I was trying to find a pattern, and then I kind of guessed on the pattern. I probably could have written it in a cleaner way so that it is more like it loops it for me instead of me manually testing test cases. But either way, I just saw that, and I saw this, but also it was a working hypothesis, right? It's not just that. It's that, okay, if you have like 1, 2, 3, and 4, right? Then you know that here, well, we know that we have at least 3 numbers of 1 bit, right? So that means that if you think about this as binary, and you have 1, you have 10, and the 3 will ignore for now, and 100. So to combine that, the 3 of these, it's going to be 111, which is 7, right? And then I thought, well, does that imply that you could do every number in between? And at this part, I didn't want to do it manually, so that's why I wrote the for loop. But then I kind of reasoned it out. And then when I ran the for loop, and you'll see this if you watch the live portion, and I ran it, I was like, okay, well, so it's complete. So then, but does that imply every power of 2 is complete? So that's basically how I kind of came up with my solution, which we'll go in more detail. But here I am going to try to work out the proof, right? The idea here, of course, it's also that n only goes up to 10 to the 5th, right? So what is 10 to the 5th? 10 to the 5th is 100,000, which is what? Actually, I don't know. 10 to the 5th is what, 16? Nope, 17. So 2 to the 17, right? Or the max is 2 to the 17, right? And I thought the idea here is that we just have to get the max number. And the max number is 2 to the 17. That means that we just need, like in a way, you just have to choose 3 numbers, but you can always get 3 numbers. And the way that I thought is that, okay, that means that in this case, you choose any number with, maybe this is off by 1, but you choose this as your first number, this is your second number, and maybe I'll line them up, actually. Maybe that's a little bit cleaner, right? Or clearer when I line them up, right? And then your third number, you choose something like this. And then you're able to get any number. Actually, technically, this only goes to 2 to the 16 because I did, no, this is right. No, this is 2 to the 18 even, but you get the idea, right? So this gives you any number here, right? And of course, now you can choose any number in between. And when you choose any number in between, you can just, do this maybe, right? And this will give you any number. So you could choose any number in between just by flipping one of these bits and choosing different numbers, right? As a result, you can do anything with just 3 numbers, it turns out, up to that biggest power, right? So here, let's say the biggest power actually turns out to be, let's just say we have an extra number, right? Or not an extra number, but just an extra row. and then now here you have something like this, and then now you remove this number, you can actually, turns out, of course, you can just put everything here, right? Oops. And then now you could just, with these three numbers, if you want to choose any number in between, right, you can just flip the bit, whichever bit you need, because you have all the numbers from 1 to n. You can choose any number, and that's basically the idea. It's that if you have 4, then and you have 100 in binary, so that you have every number all the way to 7, right? So that means that you're able to give 0 to 7, which is you go to 8 numbers. If you have all the way up to 7, right? You have 7 is the same thing, it doesn't change anything. But if you could do 8 is 1000, so you have an extra digit, and so now you're all the way up to 15, which 0 to 15 is going to be 16. And that's really the idea for this one. Honestly, I probably could have came up with this during the contest, but I was just trying to YOLO a little bit with the for loop and understanding. And this is basically the code. I just count the number of bits, like in here, and then the biggest one, I just take the power of 2, and that's it. Which is kind of what we went over. The code may look a little bit funky if that doesn't make sense, but as long as you have the explanation and visualization, I hope that you should be able to do it. And if n is less than 2, then you just return n because you cannot generate the number 0. So that's basically the reason. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live during the contest next. That kept going really poorly. All right, let's go. Q2. Okay, so nums we have a permutation array. XOR triplet is XOR of 3 elements. Okay, return the number of unique XOR values from all possible IJK. What does this mean? Number of unique triplets. What does this mean? It's a permutation. What does permutation mean? I mean, the order doesn't matter, right? So I guess, or like even the input doesn't really matter, does it? No, I guess it could. How do you get to, okay, well, well, no, the order doesn't matter. Okay, so that's 1. So you have just 0 to n, and then it's all the unique XOR values. So you have, in here you have 1, 2, which, so all the unique values of 3 of them, right? So, okay, so that means for one element is, well, has to, oh no, it could include itself. So okay, so at the very least all the numbers, so then it's just whether you can hit 0 or not. No, you can also hit bigger numbers, right? So that's not quite true. It's just that this is a little bit awkward of an example, right? So okay, 1, 2 gives you just 1 and 2. 1, 2, 3 gives you 1, 2, and 3 for sure, and then a 0. Anything bigger than, so that means anything bigger than 3 includes 0. So then 4, what does that do? 1, 2, 3, and 4. It gives you up to 7, right? Trying to think. What is the pattern here? Am I slow? I mean, maybe. Here's a 4-pointer. Okay, we know that it's at least n. Maybe. Yeah, no, it's at least n. Does the order matter? I don't think so. Because you could always do itself with itself. So all the numbers from 1 to n is possible. So it's just about the biggest number. And if it's 4, then it's but what if you add a 5? 5 doesn't give you an extra bit, so Okay, it's kind of it's more easier than that, I think. It's that you take every number before. Do you? No. Wow, I am struggling today. I feel like this is like one of those silly pattern problems that I just, today's not the day. So, okay, up to 4 to me, 7, 5, what's 5? I guess, okay, let's brute force this, right? I mean, you're not doing anything else, Larry. Oops. Okay, so this is obviously too slow, but 2 and 4, okay. And then now we want all right, let's just say 4, and that should be 7, right? Or 8? No, that, okay, that was just 0, 1, 2, 3. Okay, so that was 8 because it's 7. Okay, about 5. Okay, is it just powers of 2? I mean, I thought it was, but I just couldn't prove it. So then now would be to 8. Wait, oh no, I bought 18. Okay, I mean, I guess that is that. It's okay, so if n is equal to 1, then you just have 1. Yeah. Otherwise, then you return then the next power of 2 or something, right? So if n is 3, then you return 4. Why am I so slow on this? Okay. And then just return something like that. Okay, am I good? YOLO. Okay. Okay, a little bit sketchy on that one. Oh, there's a. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these problems, the explanation, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.